Hey Chem Kids, Campbell here. In our second video on chapter 14, we're going to talk about what dissolves. Like why, if I have some water and I put some salt in it, will the salt dissolve? But if I take some water and I put some vegetable oil in it, it doesn't dissolve. So vegetable oil and water, not dissolving. Salt and water, pretty good, dissolved. So we're going to talk about that today and also about the factors that affect solubility. So let's talk first about what dissolves in what. Why did the salt dissolve in water, but the oil did not? Well, it's all based off this thing called like dissolves like. Polar solutes, like sugar, ionic would be polar is like salt. Those dissolve in other polar solvents. So polar dissolves in polar. Whereas something that's nonpolar, like my vegetable oil, will only dissolve in something else that's nonpolar. So maybe some other oil, gasoline. So like dissolves like. So if we take a look at this like dissolves like table, if we look at our types of solutes, we could have ionic solutes like sodium chloride. We could have polar solutes like sugar or an acid like this is vinegar, or maybe ethanol. Those things will dissolve in other polar solvents. And a very good polar solvent is water. We use water a lot as a solvent because it's polar. Now, non-polar materials like the vegetable oil I put into this flask with the water does not dissolve in anything that is polar. So like dissolves like, and if it's not like it, it's not liking it. If we look at nonpolar solvents like gasoline or oil, anything that's ionic like the salt is not going to dissolve in it. Or anything that's polar like sugar will not dissolve in an oil. But anything that's nonpolar, like another type of oil, or a fats are nonpolar, or fluorine gas or nitrogen gas will dissolve in something nonpolar. So like dissolves like. If I'm like you, I like you. Now, let's talk about aqueous solutions. We talked about them before when we talked about the reaction unit. And if you remember that an aqueous solution is a solution where the solvent is water. So these are things in water. So here I have an aqueous solution of salt and water. Now, water is a great solvent. It's a great solvent, one, because I got a lot of it. But it's wonderful because it's polar. And many, many compounds that we experience are also polar or ionic. The other thing that's great about water is water can hydrogen bond with itself or other molecules. Now, we haven't really talked about what hydrogen bonds are. We'll do that when we talk about intermolecular forces in another unit. You do need to know, though, that water can hydrogen bond, and hydrogen bonding allows it to be a great solvent. Now, we need to do a little review on polarity because one of the things that you will have to be able to figure out is what dissolves in what. So you need to be able to identify something that's nonpolar and from something that's polar. Now, if you remember back to the bonding unit, nonpolar means that the electrons are shared equally between all the atoms. And one way to tell this is to look at the electronegativity difference between the atoms in a bond. So remember on the periodic table, up in the corner, there's an electronegativity value for each atom. And if you subtract the numbers of the elements that are in the bond, you find out the electronegativity difference. Well, if it's less than 0.4, that makes it nonpolar. So anything bound with itself, like oxygen or nitrogen or hydrogen, right, those would be nonpolar because the electronegativity difference would be 0. Also, if you look at the electronegativity difference between carbon and hydrogen, you're at 0.4. So this actually would make it nonpolar. So anything with just a carbon and just a hydrogen is going to be nonpolar. Now you throw an oxygen in there and that's not the case anymore. But if it's just got carbon or hydrogen, it is nonpolar. Now, a polar molecule, the electrons aren't shared equally between the atoms. And so what happens when you take that electronegativity difference, you're going to get a number greater than 0.4. Some good examples are water. Water is very polar. Any ionic compounds will have a very large electronegativity difference, usually above 1.7. Right? And remember, ionic compounds are metals bound to nonmetals. Another good example is any molecule that has an oxygen and a hydrogen bond in it, even if it has the carbon and hydrogen. So if you see oxygen, think polar. Now, the next thing I want to talk about is the factors that affect whether something dissolves or not, and then how much dissolves. And there are 3 things that affect how much solute will dissolve in a solvent. And of course, the first is, will it dissolve at all? Is it the like dissolves like? So number 1 is the nature of the solute in the solvent. Are they polar? Are they nonpolar? And I saw this little comic. I thought it was hysterical. There's that's dissolving in the water, and he's crying for help, and the bear on the iceberg is like, but bears are insoluble. And the guy in the water like, that's easy for you to say, you're not polar. Okay. All right, next factor, temperature. Now, temperature depends upon what substance we're talking about. Solids are more soluble at higher temperatures. Remember when I talked about making rock candy, making a supersaturated solution? What you have to do is you have to heat it up, because if you heat it up, you can actually get more solid into solution. So temperature, higher temperature is great for getting more solids in. But for gases, it's actually the opposite. Gases are more soluble if the solvent is cold. And think about soda, right? Soda has gas dissolved into the soda bottle, right? It's carbonated. And the warmer that bottle is, the quicker the gas comes out. So you want to keep your soda cold. Same thing with these poor little fish. If a fish pond gets too warm, then we lose oxygen out of the water, and the fishies can't breathe anymore. So gases are more soluble at low temperatures. So higher temperature, lower solubility for gases, but higher solubility for solids. So temperature, it depends. Pressure, however, only affects gases. It doesn't affect solids at all. Gases are actually more soluble at higher pressure. And if you think about your soda bottle, right, when you open it for the very first time, you hear the shh, right? Because some of that gas is getting out because it's under pressure. Because gas under pressure is more soluble. As soon as you release some of that pressure, then the soda's going to go flat a lot quicker. Another good example is if you've ever been scuba diving. If you ever been scuba diving, when you go down below, deep in the water, the pressure on you gets high, you get squeezed. And what happens is the air in your blood, the nitrogen in your blood gets squeezed, and it becomes more soluble in your blood. And so if you go up really quick, it expands, and becomes less soluble, and you get what's called the bends. It's not pretty, not good at all. So gases are more soluble at high pressure. Pressure does not affect anything else but gases. All right, that's all I got for you today. Fill out your turn-in sheet, and I'll see you in class.